All right, welcome in everybody. Today we're going to talk about section 11.6. This is in your class notes here, similar figures. I've got this blank space up here on purpose. If you're in class right now, just keep your computer shut and just watch this if you would for a moment. Here we have a triangle. Let's call this triangle A, B, C. B appears to be an obtuse angle. Let's say it's 100, let's call it 120 degrees. Which means we have how many degrees left to split between A and C? 60 degrees, right? Because the total has to be 180. So let's say we have, instead, I don't want to go 30 and 30. Let's go 28 degrees here. Let's go 32 degrees here. That's a total of 60. So there we go, triangle ABC. Now watch what happens here. If I take triangle ABC, excuse me, let's try that again. If I take triangle ABC and I'm going to copy and paste it. So I'm going to select it all, I'm going to copy it, and I'm going to paste it right there. Now I am going to change my vertices from A, B, and C to X, Y, and Z. So how are these two triangles related right now? They're congruent, right? How do you know they're congruent? Because I copied and pasted it. That means the lengths did not change, the angles did not change. These two, like two identical twins, these two angles are these two triangles are identical to each other. Hey, all right, these two triangles are congruent to each other. Now watch what I'm going to do to triangle XYZ. I'm going to select it and I'm going to shrink it down like that. Are the two triangles congruent now? Yes or no? All right, well, let's put some, I'll tell you, we got some disagreement, that's okay. So let's talk about side length AC. Let's say side length AC is a length of 20. Let's say side length BC is a length of 14. Let's say side length AB is 12. So this would all be given to you. And then let's go over to triangle XYZ, and let's say that XY, well, AC and XY, if these are drawn to scale, they're not going to be congruent. AC and XY would not be congruent. Clearly, XZ is shorter. Let's say it has a length of 10, a length of 10. So AC corresponds to XZ. XY is going to correspond to AB. The reason I know that is, notice the angles, 28 degrees, 120 degrees, over here X and Y, 28 degrees, 120 degrees. What do you think XY would be? 6, right? Well, how did you know that? It's half, right? So if AC is double XZ, then AB needs to be double XY because they're corresponding to each other. How about BC? It's going to be, well, BC is 14, YZ is going to be half of that. It's going to be 7, right? So I want you to know that triangle ABC, don't write this down quite yet, is similar to, that symbol right there means similar, S-I-M-I-L-A-R. That is a mathematical term. What does similar mean? It means the two figures are exactly the same shape, but they're not necessarily the same size. You saw me shrink the smaller triangle down. Triangle ABC is similar to triangle XYZ. Those two triangles are similar to each other. Now, in similar triangles, there's a couple things that are happening. Number one, in similar triangles, the corresponding angles, how are they related? They are the same, so we'll say they're congruent, which means they're the same, they're equal. And the corresponding sides, now, they are not the same, although they could be. The corresponding sides are not congruent. I'll tell you what they are right now. AC was 20, and it corresponds to XZ, which was 10. And that's the same thing as AB was 12, and it corresponds to XY, which was 6. BC was 14, and it corresponds to YZ, which is 7. These are all equal to each other, right? 20 over 10 simplifies to what? 2. And then 12 over 6 simplifies to what? 2. And 14 over 7 simplifies to what? 2. Does anybody know what word we would use for this, Maddie? Okay. So 20 over 10, 12 over 6, 14 over 7. These all simplify to 2 to 1. So similar figures, the corresponding sides are, starts with a P, they're what? PRO. They're proportional. They're proportional. Now, they are proportional, and we can find something called a similarity ratio. A similarity ratio. And, ooh, sorry about that. Clean that up. The similarity ratio here is, does anybody know what the similarity ratio is here? 2 to 1, right? 2 to 1. 2 to 1. Very good. Now, it's important to know that another acceptable similarity ratio for this problem is not 2 to 1, but also 1 to 2. Okay? Well, I'll tell you why. Good question. Correct. 2 over 1 and 1 over 2, they are completely different, but it all has to do with how you are looking at these two. Are we looking at them as big to small, like we did, like 20 to 10, 2 divided by 10, I'm sorry, 20 divided by 10 is 2, 14 divided by 7 is 2, or are we looking at it like small to big, 10 to 20, 10 to 20 is equal to 1 to 2, as is 7 to 14, right? 7 was here, 14 was here. They were corresponding to each other, as is 6 to 12. So if I gave you this problem and I asked you, and I told you these two figures were similar, and I asked you for the similarity ratio, there are two acceptable answers. Either one is okay. One is not more correct than the other. 2 to 1 or 1 to 2. Does that make sense? As you open up 11.6 under your class notes, there's a big blank space. That's where I wrote all this stuff here. Just to recap, corresponding angles are congruent in similar figures, and corresponding sides, I should say sides, corresponding sides are proportional. In the previous problem, we said we had a similarity ratio of 2 to 1 or 1 to 2. So let's talk about similar figures here. Scroll down until you get to this. What does it mean for two figures to be similar? It means figures that have the same shape, but they are not necessarily the same size. So this symbol right there, it's like that squiggle on top of the congruency symbol. It's kind of the same idea. It's different, but it's that same like shape. It means similar to. So if you see that squiggle by itself, it means similar. If two triangles are similar, then the corresponding angles are congruent. We talked about that already. If the corresponding angles of two triangles are congruent, then the triangles are similar. So that's enough information to know for sure the triangles are similar. If you have corresponding angles that are congruent, then you know the triangles must be similar. So that's a brief introduction to similar figures. Well, as we already talked about, what about the corresponding sides? The corresponding sides are proportional in similar triangles. So take a look at this figure. We have ML with a length of 5. We have SR with a length of 15. What is the similarity ratio here? All right, you could divide by 3, which would say 1 to 3. So you could say 1 to 3. Or you could say what? 3 to 1, right? You could multiply by 3. 5 times 3 is 15. 15 divided by 3 is 5. Let's do the same thing with the other sides. 3 multiplied by 3 is 9, or you can say 9 divided by 3 is 3. And then same thing with the last pair. 6 multiplied by 3 is 18, or 18 divided by 3 is 6. So the similarity ratio here is 1 to 3 or 3 to 1. I don't know the angle measure of L. I don't know the angle measure of R, but whatever they are, they have to be what? Equal. They have to be equal. They have to be congruent. I don't know the angle measure of M. I don't know the angle measure of S, but whatever they are, they have to be what? Congruent. And same thing with N and T. And as we already talked about, we can compare the measures of corresponding sides by using ratios. All right, so let's take a look at these two triangles. Triangle GHI, this is called a similarity statement. We learned yesterday about congruency statements. Today we're going to talk about similarity statements. Triangle GHI is similar to triangle JKL. We want to find the value of x. Set up a proportion using the known measures and solve for x. So see if you can do this now using a proportion. I know you probably don't have to even use a proportion. If you know the answer by looking at it, that's great, but still use a proportion just to prove your answer correct. So I'm going to pause the video now. You should do the same thing and work that problem. All right, let's take a look. So we're told these two figures are similar to each other. Now these two, it's clear what corresponds to what because they're like kind of the same size, or sorry, they're the same shape and they're oriented the same way. So it's pretty easy to see that GH corresponds to JK. But if you weren't able to easily tell, you can use the similarity statement. First and second GH corresponds to first and second JK. So I'm going to write it like this: GH to JK, and then I'll sub in values for those in just a second, is equal to, I also have information on HI and KL, so let's take a look at that. HI is second and third, KL is second and third. So I did triangle on the left in the numerator over triangle on the right in the denominator. So I'm going to keep that same theme going. HI in the numerator over KL in the denominator. So that's the proportion I'm going to set up, and I used my similarity statement to help guide me in setting up that proportion. So now let's plug in the values. 12 to 4 equals 9, which is HI, to X. How can we solve this proportion? 2 words. Emma? All right, well, 4 times 9, it's called cross multiplication, equals what? 36. And then 12 times x is 12x. We can divide both sides by 12. What's 36 divided by 12? All right, so x equals 3. What are our units going to be here? Centimeters. X equals 3 centimeters. Now, you probably look at this and you're like, that wasn't necessary, Mr. Rivers. I can look at it and just tell 4 times 3 is 12, and something times 3 is 9. That something has to be 3. That's great. I love that you can do that. And you should lean into that. But you also should know how to set up a proportion, and you should know how to solve that proportion. And you should also know how to use the similarity statement to help guide you. So like this problem on purpose was a lot easier than many of the problems, but these two figures are going to get rotated, they're going to get flipped, they're going to get reflected. A lot of things are going to happen where it's not going to be so clear what corresponds to what, and you are going to need to use the similarity statement. Yeah. We had a great question in class by Callie. And she asked if the order within the proportion matters. And the answer is kind of yes and kind of no. This is just one of the many acceptable proportions we can set up. Another one would have been JK over GH, which is equal to KL over HI. And again, you could use this similarity ratio to help guide you with that, but it's just the exact same proportion flipped. Or you could do, this would also be okay. I'm sorry, GH. Thank you very much, Graham. That should be GH. Sorry about that. Or we could take the numerator. We could say numerator GH over the other numerator value HI is equal to JK, that denominator value over the other denominator value, KL. That would also be okay, as would the reciprocal of both of these right here. So there's a few different proportions that are okay to set up. That's just one of them right there in red. Try this next one on your own. Triangle JUD is similar to triangle ITH. Find the value of x, give that one a shot. Set up a proportion and solve. So on this problem, we're going to set up a proportion again. There's a few different proportions that are okay. Notice we have information on DU. DU is right here. DU is third and second, so I'm going to say DU. And what does DU correspond to? HT. DU over HT. Yeah, you could say UD. That'd be fine. And that is equal to, okay, so I'm going triangle on the left in the numerator, triangle on the right in the denominator. So here we go. What else do we have information on the triangle on the left? We have information on JU. So JU, I'll put that up in the numerator. And that corresponds to, let me go back to my similarity statement. JU is first and second. Well, IT is first and second. IT. You don't have to show this, but you should be thinking that at a minimum. If you do want to write it out, I think it's a good habit to be in. DU is 12 over HT, which is X. And that is equal to JU, which is 9, over IT, which is 6. And from here, we cross multiply and solve. 9 times X is 9X. And 12 multiplied by 6, that's 72. We divide both sides by 9, and we end up with X is equal to what? 8. So 8 feet. Please include your units there if units are given to you. So you should have had 8 feet there, and I do need you to be able to set up a proportion. I do need you to be able to solve that proportion as well. Let's take a look at this example now. It says use the information below to find the value of X. So these two triangles, they are similar to each other. And let's talk about what is congruent to what. We see that angle A has one arc and angle D has one arc. So let's write the following. Triangle A, and then I'll leave a blank space, It's going to be similar to triangle. All right, well, A is first, so D is going to have to be first because those angles are congruent to each other. Also, B is a right angle. E is a right angle, so B and E, they're congruent. So we'll say B is second, and E has to therefore be second. This is not the only true similarity statement, but wherever you put A, I put it first. D has to be in the same spot. So if A is in the first spot, D needs to be in the same spot. If A were in the second spot, D would have to be in the second spot. Same thing with B and E. And then here at vertex C, we've got a vertical angle there, and we have a vertical angle there. So C corresponds to C. So triangle ABC is similar to triangle DEC. So now that you know that, set up a proportion and solve. We are missing the side length for ED. So see if you can set up a proportion and solve for the missing side length ED. My recommendation is you use the similarity statement to guide you along. So try that one out on your own. So what you need to know about this one is there's a number of different proportions that are acceptable. Right away, I notice, okay, well, I've got this side length of 20. I like that that is like a nice round number. What is 20? It is side DC. So that's first and third. Connor, what does DC correspond to? AC. Which is first and third, right? So we'll say DC over AC equals, okay? And by the way, this is not the only proportion that works. If you set up a different proportion, it probably, and it worked, you're fine. You're totally fine. What else do we have information on? We have information on, well, I'm trying to find ED. Okay, so I said DC, which is in this triangle on the right, the triangle up top. That's in the numerator. So I got to keep that in the numerator. So we're going to go ED in the numerator. Nicholas, what does ED correspond to? What'd you say? Yep, so ED is second and third. AB or BA is also second and third. So there you go. Yeah, so you could have used that as well if you wanted to. What did I do? ED, second and third, first and second, same thing. So ED and DE are the same thing. So if I told you to look at side ED, you would look right here. If I told you to look at side DE, you would look right there. It's the same side, whether it's called ED or DE. It's the same thing. There's another part of this proportion that we didn't have to use. The key here is this missing side, which is ED. ED has to be in the proportion you're using. Let me go ahead and finish this one out because you may have had a third piece to this. What side have I not used yet? I've not used this side right here, EC. Where is EC? It is second and third. EC, second and third. What does EC correspond to? BC, which is also second and third. So EC and BC, they are corresponding to each other. Second and third corresponds to second and third. Now, the key here, as we talked about, is ED. Everything that I'm interested in is ED because that's my missing side of X. So I'll take this part of my proportion. DC over AC equals ED over BA. Or I could take that one if I wanted to. Either one is fine. It's going to work the same way. I just have to make sure I got ED in there because that's that missing side that I'm trying to find. Leave that on the floor, please. I hate those things so much. Why are the water bottles 35 pounds each? Why are they so heavy? It just okay. All right. I hate these things so much. All right. Sorry about that. We had a water bottle fall and it startled me and upset me. Okay. DC over AC. DC, let's plug in now. DC is 20. All right. So again, DC over AC. DC is 20. AC is equal to 12.5. And that is equal to ED over BA. ED is X. BA is equal to 10. BA is equal to 10. So there you go. So once you have that proportion, you can cross multiply and solve. If you had a different proportion, you probably still got this right. There's a few different proportions that work. 20 times 10 is 200. 12.5 times X is 12.5X. Then we're going to divide both sides by 12.5. What'd you guys get when you divided 200 by 12? 16. So X equals 16 feet. So the takeaway from this is if you had a different proportion and you still got X equals 15, your proportion is good. There are many different proportions that work. If yours is not exactly what I had, it's probably not exactly what I had. That is okay. The key here is that when we set up our proportion, we are putting corresponding parts in corresponding positions. All right, we're going to work this one, then we're going to go on to IXL. Try this one out. Use the information below to find the value for X. Number one, I want you to write a similarity statement. Number one, write a similarity statement. After you've written a similarity statement, I want you to, number two, write a proportion. After you've written a proportion, I would like you to solve. So those are the three steps I want you to use right now to find the missing side MA. All right, so if you're watching the video, triangle RSF, what is R congruent to? R is congruent to P. So if I have R first, I need to have P first. If you didn't put R first, that's fine. Just make sure R is in the same position as P. S, I put second. What is S congruent to? It's congruent to M. So if I put S second, I have to put M second. They don't have to be second and second. They could be first and first. They could be third and third. And then finally, I put F last. And if I put F last, I would have to put A last because F and A, they are congruent to each other. Just make sure you have congruent parts in corresponding positions. R should be in the same spot as P. S should be in the same spot as M. By that I mean like first and first, second and second, third and third, etc. Same thing with F and A. All right, so pause the video now. Keep working if you have not finished. All right. So as we take a look at this, we have our similarity statement. There's a few different similarity statements that are okay. I noticed right away I've got information on FR. All right, so we use FR. FR, that is, guys, please stop talking when I'm talking. Noah, please stop. Okay, so FR, that is third and first. AP is third and first, so FR corresponds to AP. And what else do I have information on? Ooh, sorry about that. I also have information on, one second. Let's see. We have information on FS. FS, that corresponds to, well, that's third and second, AM. AM. So this is not the only similarity, this is not the only proportion that works. You could also have the reciprocal of both of these. You could have AP over FR equals AM over FS. That would work. You could have FR over FS equals AP over AM. That would work. Or the reciprocal of that, that'd be FS over FR equals AM over AP. Any of those are okay. But once you have your proportion, we're going to substitute in the values here. So FR is 7.5 over AP. AP is 15. And that is equal to FS. FS is 9 over AM. AM is X. So then we cross multiply and we solve. 7.5 times X is 7.5X. and that is equal to 15 times 9, which is 135. When we divide both sides by 7.5, somebody help me out. What is 130? 18. So you should have had x equals 18. So if you had a slightly different proportion, but you still got 18, then your proportion was one of the ones that was good. It's just important that we put corresponding parts in corresponding positions. All right, so if you would right now, go to IXL AA.17. I'm going to walk you through this one. So go ahead and get there now. I'm going to pause the video. You should pause the video too to get to AA17. So typically in geometry, we want to have proof of what corresponds to what. This is one of those rare cases where we're going to assume that what looks congruent is congruent. So it says here, if these two figures are similar, what is the measure of the missing angle? What do y'all think it is here on the board? 68 here, that's going to be 68 as well. So the acute angle in these two similar figures. So 68 and 68. There we go. Let's try a couple more. If these two figures are similar, what's the measure of the missing angle? Where's the missing angle? Right there. What does that angle correspond to? That one right there. In similar figures, corresponding angles are congruent. So if this is unknown, it corresponds to that angle right there. That's a 90-degree angle. So the missing angle I have is 90 degrees. All right, now we got sides in this as well. If these two shapes are similar, what is the measure of the missing length u? All right, so let's take a look at this. We have a shorter side, which in this case is 6, and a shorter side, which is 1. We could set up a proportion. This one's easy enough to where you don't have to. 1 multiplied by 6 equals 6, or you could say 6 divided by 6 is 1. 12 divided by 6 is 2. So U is going to be 2 kilometers. Again, my similarity ratio here is 6 to 1, or you could say 1 to 6. 6 divided by 6 is 1. 12 divided by 6 is 2. So U is 2 in that situation. Let's try a couple more all together, and you guys can try it on your own. On this one, we have a longer side of 12, a longer side of 4. We have a shorter side of D and a shorter side of 1. 4 multiplied by 3 is 12. 1 multiplied by 3 is 3. 3 yards is my missing side length there. So that's all there is to here. Just find the corresponding parts and find the missing angle measures and the missing side lengths. Thanks for watching. Good luck on IXL AA.17.